kinematics and describing motion. So kinematics measures the positions, speed and velocity, and acceleration. So what is motion, guys? So vocab alert. So motion, there's going to be a lot of that today. So motion is when a system's position changes during an interval of time. So depending on number of axes in the frame of reference, it may take multiple coordinates to identify this position. So what is an axis? The plural of axis, so A-X-I-S, so like the lines in a graph, are the reference lines along the dimensional units being measured. So it's like multiple. Okay. So one-dimensional motion, only one. That's one singular coordinate needed to identify a system's position, or we could call that x. So if it's only one dimension, but if it's two, like this, not just this, it's x and a y. Okay, that would be axes. Okay, so vocab alert. Distance is a positive scalar quantity because there's no direction associated, so it could be in any direction. And displacement is measures starting point to end point, so it's a straight line from that. So like the starting point from this hand to this hand would be this line. That is my wingspan. So magnitude of a number or vector is its absolute value, so it's always positive. Okay, guys? So magnitude is length, and a vector is the direction of the system or the line that is going. So magnitude of a displacement vector and distance traveled are equal only when object traveled in a straight line. Okay? Straight line. So it's always true in one dimension. So speed and velocity. So rate of motion is speed. Okay? Speed. And is always positive because distance and time is always positive. So that's distance over time interval gets you speed, and because those are always positive, positive times a positive or dividing is always positive. Okay, guys? So another vocab alert, okay? Ready? Just ingrain this into your brain. Instantaneous speed. The actual speed at any moment, guys, any moment, lower or higher than average speed of a system for entire interval. Entire. Remember that. Okay, so when you calculate speed from total distance and the time it took, you are calculating the average speed. Another vocab alert. So average speed is constant speed. So there's no slowing, no speeding. It's constant. The same thing is happening. Okay, so velocity, another vocab. Rate it takes to complete a displacement. So like the time it takes to get from point A to point B in this straight line. So as long as the system's direction of motion doesn't change during the time interval, the distance and displacement will be identical. Okay. And so formulas for finding speed and velocity contain three variable quantities: distance, time, interval, and speed. They're key. So useful because they're knowing any two quantities helps you find the third. So knowing speed and velocity, or well, knowing the speed and the time can help you find the velocity, or the other way around, vice versa. You can solve using a simple algebra formula, which I forgot to write down, but it's alright. So acceleration, guys, we did a lab yesterday about it. So it's the rate of change of speed or velocity during a given time interval. Okay, so increases speed or decreases or change of speed. So something is changing. Okay. So with velocity changes, it can include a change of speed, direction, or both. It could be all of the above, guys. So it includes both speed and direction when dealing with acceleration. So now, motion in 2 and 3 dimensions. So now we're not in 1, not just 2, but in 3. So here we go. So this course includes one-dimensional only, usually, but most real-life stuff happens in 2 to 3 dimensions. So like, I'm 3-dimensional because I take up space, you know? Yeah. So motion in 2 dimensions involves changes of position on a coordinate plane. So for example, cars on a road, like driving, or players on a field, That's an example of horizontal plane. Okay, guys? So that's like this way. Okay. And vertical planes, on the other hand, an example would be a path of a thrown ball. So if I just like threw a Sharpie just on the floor, that's vertical. Okay? That's an example. There you go. So position in plane is determined by two coordinate axes, so it's perpendicular. That means like there's one point that they're meeting at, okay? And that point is called the origin, also known as the coordinate 0, 0. So remember origin, guys. And this is described by two coordinates, so example, x and y. So like before, a system's position in one dimension would just be x, like a point. And now, if it's two dimensions, x, y. There you go. Thank you for giving me your attention. I am done.
Yay!